in this figure, what we can see, current through the 4 ohm resistance is Ix, and the voltage across the dependent source, current controlled current source, Vx. So we have to find out Ix and Vx using superposition theorem. Superposition theorem tells that current through any branch or a potential across any branch is the algebraic sum of current or potential across is the algebraic sum of current when individual sources are acting alone. That means we have to use one source at a time, and finally this current, here there is one voltage source, one current source, independent voltage source and independent current source over here. So this is the independent voltage source, independent current source. We cannot replace the dependent current source or voltage source. So we have to find out Ix. So finally this Ix will be Ix1 plus Ix2. As there are two sources, and this Vx is equal to Vx1 plus Vx2. So now we will solve this one. So first we will use 1 ampere current source acting alone. So when 1 ampere current source are acting alone, we have to replace the other by their internal resistances. So we don't need this one, we will replace it by short circuit. So this is replaced by short circuit. Now what we can see, this one is a single node. Single node. And let the current through this 4 ohm, this Ix1, and the voltage is Vx1. When 1 ampere current source is active alone, so now I have to write the equations. What we can see, this voltage Vx1, as this is only a single node, so I can see this Vx1 over across this same voltage. So in this branch, current through 1 ohm is Vx1 by 1 ohms. Here it is Ix1. So I can write Ix1 plus Vx1 by 1 plus 1 ampere, because all these are in this direction, and 3Ix is the opposite direction. So this is equal to 3. Here also it is Ix1, 3Ix1. So when I am using 1 ampere current source alone, that time I replace the Ix at Ix1. So this will be the output of the current controlled current source 3Ix1, and this Vx will be replaced by Vx1. So in this equation I can see ix1 plus vx1 plus 1 is equal to 3ix1. So this is 2ix1 and this is equal to minus 1. And what I can write, vx1 is equal to 4ix1. I can write, this is one equation. Another equation is four ix1 is equal to vx1. It's correct. So now I can, this is equation 2. So from this equation I can write ix1 plus 4ix1 plus 1 is equal to 3ix1. Now here it is 5ix1 and there it is 3ix1. So 2ix1 is equal to minus 1. So ix1 is equal to minus half ampere. So from equation 2 what I can write, vx1 is equal to 2 into ix1, that is 2 into minus half, 4 into minus half. So this is equal to minus 2 volt. So what I have got, ix1 is equal to minus half ampere and vx1 is equal to minus 2 volt. So these two are important. Now when two volt source are active alone, so now 2 volt source is active alone. So what to do? So I will open this one. So this source will not be there. Only 2 volt source will be there. And this ix will be ix2, this will be 3ix2, this will be vx2. So what I can write, 4ix2 is equal to vx2. So 4, the voltage drop across it, as this is, again this one is a single node. So 4ix2 is equal to vx2. So this is one equation. And another equation is current flowing through 1 ohms. The potential of this one is the Vx2 and here it is 2 volt. The current through 1 ohm, say this current is I. Let the current through 1 ohm is equal to I. So this I is equal to Vx2 minus 2 volt divided by 1. So this is my equation 2. So here I can write this I plus Ix2 is equal to 3Ix2. So from here what I can write? This current in this directions. So I plus Ix2 is equal to 3Ix2. So I is equal to 2Ix2. See the equation here, I know that I is equal to Vx2 minus 2. What is Vx2? Vx2 is equal to 4Ix2. So if I put the value of Vx2 as 4Ix2, so I can write this is equal to Vx2 minus 2. So 4Ix2 minus 2. So from this I can write two Ix2 is equal to 2. So Ix2 is equal to I is equal to 1 ampere. Now what is Vx2? Vx2 is equal to 4Ix2 4Ix2. So this is equal to 4 into 1, 4 volt. So according to superposition theorem, Ix is equal to Ix1 plus Ix2. So this is equal to minus half plus 1. So this is equal to half ampere, and Vx is equal to Vx1 plus Vx2. There is algebraic sum of voltages when individual sources are active alone. So this is equal to Vx2 is equal to 4 volt and Vx1 is equal to how much? Vx1 is minus 2 volt. So this is minus 2 plus 4. So this is 2 volt. So this is the answer. So when you use superposition theorem and dependent source, you have to solve the problem in this way. Thank you very much for watching.